Good afternoon. Today we are to consider equilibrium of a rigid body under the action of coplanar force system. Thus, let us consider a ratchet wheel hoist. The ratchet is used for holding a body in a given position. Let us make a statement of the problem. The hoist is equipped with a ratchet wheel of diameter d1 with a pole, a drum of diameter d2 is connected fixedly with a wheel, and on the drum a cable is wound that holds the load of the weight Q. Find the pressure on the axis of the pole. The weight of the pole can be neglected. The system comprises two bodies. Let us divide the problem into two parts. First, we consider equilibrium of the pole. Let us construct a free body diagram. The tooth wheel and a joint on the point B are the constraints for the pole. Reactions in the points A and B are illustrated in the drawing. The reaction of the joint in the point B is equal to the pressure that the pole is exerting on the axis. The typical sizes of the pole are specified in the drawing. It can be seen from the drawing that the body is in equilibrium under the action of two forces. According to the first axiom, these forces are equal in magnitude, are of the opposite directions, and are collinear. To proceed with the calculations, we need to know a cosine of alpha angle, which can be calculated from the characteristics in the drawing. Let us consider equilibrium of the ratchet wheel. To compose a free body diagram, we mentally remove the constraints and replace their actions with the corresponding reactions. The pole and the joint in the point O are the constraints for the ratchet wheel. The reactions are shown in the drawing. The reaction RA prime is equal in magnitude with the reaction RA and is of the opposite direction. The reaction on the joint in the point O is resolved into two components, the component along the axis X and the component along the axis Y. Along with these reactions, the force Q is acting on the wheel. To find the reaction RA prime, let us write down the moment equation. The moment of the force Q with respect to the point O is equal to the magnitude of the force times the arm. The arm is the distance from the point O to the line of action of the force. The force is tending to rotate the wheel counterclockwise. To find the moment of the force RA with respect to the point O, let us resolve it into two components. The component RAY and the component RAX. The line of action of the component RAY passes through the point O, so its moment is equal to 0 with respect to this point. For the component RAZ, the moment is equal to the magnitude of the force times the arm, where the arm is the distance between the point to the line of the component's action. The component RAX is tending to rotate the body clockwise, so it is included in the equation with a minus sign.
Let's define the unknowns from the derived equation.